this video is for all the students in our summer kids college at Northeastern Junior College. I'm going to start by going through some of the components that you guys received in your electrical kits. All right, so some of the components that we have. We have several devices that create energy. You guys are probably familiar with batteries. These are 9-volt batteries. You guys also have solar panels. And these will create, if you look on the back, about 2 volts, 200 milliamps of current when placed in the sun. You'll probably only get about 1.5 volts, similar to like a AA battery. Okay, you guys will also have, so these create energy or voltage. You guys also have things that use that energy that you're creating. Okay, you've got LEDs, light emitting diodes. Okay, you have motors. These are 5-volt motors, and you have a fan. This is also a 5-volt fan. Okay, now between these two, normally in an electrical circuit, you have components that transfer the energy from one side to the components that use the energy. And in that case, you would have wires. So you guys would see wire kits. Your battery connector is also one. Okay, that hooks to the battery. That transfers the voltage out of the battery to the ends of the wires. In a lot of cases, you'll put switches or that type of stuff between this to turn things on and off. So you put a switch between the power source and the thing that's using the power to be able to turn it on or off. All right, so we're going to go through some safety before we get started. All right, so first thing, guys, you should always have your safety glasses. When you're dealing with electricity, just wear them. Sometimes things catch on fire, sometimes they blow up. So safety glasses, you need to have them on. With the voltages that we're going to be using, the 9-volt battery or the solar panel, there's not enough here to shock you, so you don't have to worry about getting shocked. But if you ever go up to higher voltages, which I don't recommend until you get some formal training or with supervision, then you can get shocked and you have to use different equipment. But for our circuits, simple safety glasses, you'll be okay. All right, so safety. So with our glasses on, the biggest thing about safety on electronics is a fire hazard right now at the low voltages that we have. So you guys all know if you take a battery and short it together, the battery explodes, right? It's because the electricity stored in the battery is going to flow through this loop, and there's nothing here to stop it. So if I touch it, okay, so let's try this again. So if you touch a battery, what leads together, they usually spark. I'm failing miserably here. So the biggest part of safety is you got to understand how these things work so you can keep the thing from burning up. In this case, I have 9 volts going through I think a 15 ohm resistor. And because the voltage that I have going through it, this resistor is getting very hot. All right, so we have electricity flowing through this resistor from the battery source through the wires into this resistor. This is a 15 ohm resistor, so the current flow, this is very easy. I know you guys don't like math, but there's a very easy formula to determine what the current flow is, the amount of electricity that's flowing in this loop. Okay, and it is I is equal to V over R. So the current that's flowing, the amount of electricity, the electrons, is equal to the voltage that I'm applying. So in this case, I have 9 volts. So voltage divided by how much resistance I have in ohms. So my resistance. Okay, very easy formula. Okay, so in this case I have 9-volt battery, 9 volts, and I have a 15 ohm resistor. So if I divide that, okay, so if I divide 9 volts divided by 15 ohms, I get 0.6. And in this case, it's current, so it's going to be amps. Okay, or if you have been through metric conversions, that's also equal to 600 milliamps of current. All right, so I'm going to explain basic electricity, voltage and current. A lot of people get confused about it. So voltage, like what would be stored in a battery, is stored energy. Okay, in our case, the way we do it is we would separate the positive and negative charges. Okay, so you guys know from science classes, if I take positive and a negative charge, okay, and I separate them, they want to attract, right? So the negative is going to go towards the positive. Okay, with electricity though, it's a special use. I would take negative electrons, so I'd rip all the electrons off of one side and I'd have more on one side than the other. Okay, and this one, let's just say, has fewer electrons. Okay, so the difference between that side and this side, there's more electrons down here than there are there. So that is your voltage. Okay, that's the more electrons that I separate off of from the positive charge, the more energy I can store in the battery. Okay, so what I do with electricity is I harness this. The electrons always want to move towards positive. Okay, they want to go that way. They're negative charges, so they always want to go that way. So I take a piece of wire and I put it between it and I allow give the electrons a path to flow. Okay, but it's controlled. So in a piece of wire, I would basically have a piece of wire here, and I'm giving them a path, like a highway. Okay, once I connect my positive side of my power source, so a battery, so in this case this side, to the negative side of my wire, my electrons now have a path. Now that's really not that useful, so usually I take something that I want to do something with it. I want to light something up. So I'm going to put an LED in there. And I want to take advantage of the fact that these electrons want to go to positive, and as they flow through this LED, they create light. Okay, but I can also use electricity in other ways. Okay, I can use electricity to create motion. So my electrons will flow through my DC motor in one lead and out the other, trying to get to positive, and it will cause this thing to rotate. Same thing with a fan. In that case, I'm just creating motion. With resistors, I can actually create heat, so just a heater. So I needed to keep something warm, so I'd use a resistor to take advantage of the fact that the electrons want to go to positive, and my resistor would warm up, and I could keep something warm, let's say. That's the end of the first video. Thank you guys for watching this. In the next one, I'm going to show you guys how to hook up and use a breadboard and hook your batteries or your solar panels up to create some motion and some lights. Thanks.